Welcome back. This week we're going to continue our discussions of various active learning strategies, including problem-based learning. Trina, what's your experience with problem-based learning?
I actually use an approach that I would categorize as problem-based learning in the course that I teach most frequently, which is an introduction to environmental engineering. So it's a pretty, I would call, large course by my standards. It has about 100 students. It's a required course for civil and environmental engineering majors. And we cover some really fundamental chemistry concepts in that class that govern how pollutants move through the environment. And as you can imagine, a lot of civil engineers want to build bridges, not so interested in chemistry, so it gets really hard to get them to buy into why they need to understand these core chemistry concepts. And one of the really fundamental concepts we cover is called Henry's Law. Now, Henry's Law governs how chemicals partition across gas and water phases, so it's really important for figuring out where pollutants go in the environment. But it includes an equation and some arcane chemistry principles, and it's just really hard to get the students to pay attention to that. So what I found works really well is if I present them with a real-world problem that's actually a pretty hard problem, something like imagine that there's a gasoline spill in Lake Michigan and you have to go out and clean it up as a real-life environmental engineer. And I have them work through sort of what they need to think about in order to tackle that real-world problem and what concepts would they need to know in order to solve it. And they kind of lead themselves to the realization that they need something like Henry's Law in order to solve it. And so then I can go and present the equation, I can talk about the chemistry they need to know, and they're much more engaged, much more willing to realize that they have to learn some chemistry in order to be a good environmental engineer. So I buy it, hook, line, and sinker.
Nice, nice. No, that's a great example. We're going to be looking at problem-based learning, but we're going to start with a module on inquiry-based labs. So kind of taking some of these approaches to the lab environment. A lot of us in the sciences and engineering teach labs in one fashion or another. Our module on inquiry-based labs has been developed by Cynthia Brain. She's my colleague at Vanderbilt University. She's an assistant director at the Center for Teaching and a senior lecturer in biological sciences. She was also a professor of biology at Centenary College, a small liberal arts college, before she came here. And so she's got a lot of experience. In the module, she's going to share some case studies from biology and from astronomy to kind of see what inquiry-based labs might look like. What does that mean? And really, there's a strong theme of helping students start to practice the kind of cognitive skills that scientists use, help them to start to think like scientists, really.
Very cool. Our second module is going to be on problem-based learning, and it's been developed by Rick Campa at Michigan State University. We're going to focus on problem selection and design. So how do you choose the right complexity of problem, and how do you put it together so that it maximizes the student's ability to really grab onto it? And also building on learning principles to structure, very specific learning principles to structure learning activities.
Great. So as we go into these modules, you'll learn a little bit about the evidence to support some of these strategies, but we also encourage you to continue thinking about the types of questions or problems you might want to grapple with in your own classroom if you were to implement some of these modules.